In this vast world, things work in nature's way. Airflows interact while rising and falling. Warmth and cold alternate and balance. The most common natural phenomenon is derived from energy conversion. The wind, a resource with a vast amount of reserves, inexhaustible and omnipotent. We revered it once, then tried to find our way around it, and finally used it for our own good. We started with irrigation devices, then used wind to husk grains and smelt iron. We reclaimed land from the sea and sailed to the vast beyond. Humankind never stopped, further exploring the wind. Today, humankind still worships the power of the wind. We are using methods that our ancestors couldn't dream of doing whatever we could to develop this type of ideal renewable energy. China is one of the first countries to utilize wind energy. Spread from the boundless ocean to the highest ridge of the world, harnessed wind energy is injecting China's green-oriented transition of energy with endless transparent power. A day begins with buzzing catch trades. Marine products caught from the South China Sea are already served as food in the GHM Greater Bay Area. What this seaside town offers to the Greater Bay Area is more than just delicacies. Here, 26 kilometers south of Shapa Town, Yangjiang City, wind from the sea is strong, crossing through towering wind turbines. CTG Yangjiang Shapa Offshore Wind Farm is the first offshore wind farm that reached the million-kilowatt class in China. With the total installed capacity reaching 1.7 million kilowatts, it provides the GHM Greater Bay Area 4.7 billion kilowatt-hours of clean electricity per year, supplying approximately 2 million households with electricity for a year. That surging electrical energy was generated from the 269 wind turbines in this area of the ocean. This new force that joined the family comprises 43 units of 7 megawatts typhoon-resistant offshore wind turbines. The one who sent them to the sea was a wind turbine manufacturer who, though located in the Sichuan Basin, is connected to the ocean in every way.
We have a long coastline. Our offshore wind power resources exceed 700 million kilowatts. The 3060 dual carbon goal mentioned by our General Secretary has benefited the wind power industry greatly. In 10 years or even longer into the future, the clean energy installed capacity per year in our country will exceed 100 million kilowatts.
The impeller diameter is 186 meters, and the blade length is 91 meters. The swept area equals 3.7 standard football fields, generating 7,000 kilowatt-hours per hour. Liu Shihong and his team developed the 7 megawatts typhoon-resistant offshore wind turbine so strong that the electricity generated takes up more than 21% of the entire wind farm. However, if one focuses solely on these strong numbers, they may miss out on some interesting information. In the thousands of parts in the wind turbine generator, the huge blade can hardly maintain a low profile. It is the heart and the power source of the system. The thin shell structure comprises the outer shell, the beam, the plate, the matrix, the core material, etc. The larger the blade, the more wind energy is captured. To ensure that the blades can continuously function in a special environment without breaking for 20 years, the manufacturer must find suitable special materials for this job. In those square containers is a type of high molecular polymer. Epoxy resin is the core material of wind turbine blades. Its performance directly determines the quality of wind turbine blades.
Epoxy resin used to produce wind turbine blades is similar to the paste ancient people used to make traditional shoes. The material is the most critical one for wind turbine blades. This product used to be monopolized by foreign chemical giants. We were determined to produce this by ourselves, and we struggled for a few tough years to reach that goal.
The world is undergoing some huge changes in a century. Technology is what determines a country's future. As one of the three key technologies in the 21st century and the foundation and forerunner of high-tech development, new materials are not only the key to a country's high-end manufacturing, but also one of the focus domains of international competition. However, the supply chain for key wind turbine blade materials has long been controlled by Western companies. To break the technological blockade and monopoly and bring more stake to our own hands, we can only trust ourselves when it comes to the critical core technology. In 2 decades, Chinese turbine blade manufacturers, though started late, have become black horses in critical areas. From chasers to leaders, they've come a long way. The 672-hour trial has begun. From a drop of liquid raw material to a solid-state sample available for testing, the epoxy resin must survive long and wholesome testing. There are over 20 stages, and the sample has to clear them all in one chance for the epoxy resin to be qualified as part of wind turbine blades. This process is like progressing in a kung fu movie. The equivalent value test is ended. Its activity meets the standard. The rheological properties test is completed. The requirements of the perfusion process are met. In these most basic trials, epoxy resin faced them like a breeze and performed well. Next, it will realize its transformation through a process including ratio mixing, vacuum defoamation, vacuum infusion, heating, and solidifying. Once fully merged with the reinforced glass fiber, the epoxy resin has entirely changed, speaking from whether the outer form or the internal molecular structure, turning into a fiberglass composite material. If these tests are entry-level, then the next one coming up can be described as harsh punishment. An electronic universal testing machine, the ultimate havoc wrecker for engineers. It will do its best to apply destructive forces to epoxy resins, to acquire key data of the epoxy resin, including the ultimate tensile strength. With a speed of 2 millimeters per minute, the stretching is difficult to detect by the naked eye. When the tensile force gradually rises to 40 kilonewtons, the ultimate havoc wrecker finally got what it wanted. But this is not the end. The fatigue testing begins. The test will verify the service life of wind turbine blades. The fatigue testing machine is adjusted to the frequency of 5 Hz and stretching epoxy resin with stress ranged 350 to 700 million pascals up and down in cycles. Usually, epoxy resin would go through tens of thousands of stretching cycles to prove that it meets the requirements for a wind turbine blade material. With 30,000 yuan and 8 people, they started from scratch. And now their annual output value exceeds 2 billion yuan. Their wind power epoxy resin market share maintains one of the top 2 in China. They are the manifest of the vitality and strong resilience of Made in China and its steady development into a better future. Today, the new round of world sci-tech revolution and industrial change is integrating with the optimization and upgrading of China's economic structure rapidly. Facing new technological revolution and industrial transformation, sci-tech self-reliance and self-strengthening are not only the strategic beam for China's development, but also the foundation for Made in China to achieve innovation-driven development and comprehensively foster new strengths for growth.
According to the weather forecast, we have a window of about 3 days. Before performing electrical work, cut the power and check the electricity. Be sure to work only when the electricity is cut off.
At 6 o'clock in the morning, the maintenance team boards the ship on time and sails off. In the next 3 days, they will inspect and maintain 43 7 megawatts typhoon-resistant wind turbines one by one. A week ago, Chaba, the first typhoon that landed in China this year, struck Guangdong head-on. The maximum wind force near the center reaches level 12. Those 7 megawatts typhoon-resistant wind turbines, which have been in operation for almost 6 months now, are facing a severe test. To the relief of the engineers, despite the great power of Chaba, the turbines are not showing any extremely dangerous working conditions, including blade damage, overturning, or tower failure. Now they must make use of the short window allowing operation and restore problems left by the disaster fast by troubleshooting every possible hazard.
Here, Lin Sin, let's check that generator.
All right.
The first to be inspected is Unit 140. The diesel generator fixed on the lower sinking platform is the focus of the inspection when the typhoon comes and the wind speed exceeds the set safe wind speed. The diesel generators will be activated to ensure that the turbine is facing the wind, to reduce the load shock on the turbine. They were worried that the bolts of the diesel generator had loosened or fallen off, or there had been an oil leakage.
The marking line is clear and unshifted bolts are tight.
The inspection results brought them relief. At the same time, Liao Shujia, an engineer, has boarded the nacelle 91 meters above the sea. After confirming that the electric energy reserve of the backup power supply of the unit pitch system is intact, he proceeds to check Unit 140 for the wear and tear of the generator grounding carbon brush. When encountering complex weather such as typhoons, the turbine will be forced to take temporary emergency measures such as power outages and shutdowns. In order to reduce load impact, the impeller will rotate with the wind. But if the impeller turns too fast, the wear and tear of the generator grounding carbon brush will worsen. Liao Shujia is lucky. All systems and equipment of the unit, including the generator grounding carbon brush, are still in the prime state. Unit 140 has smoothly passed the huge impact of Typhoon Chaba.
The 7 megawatts model is a new model. By September 16 last year, the last turbine was installed. All turbines were connected to the grid on December 16th. That is something we, the ones who were on site, felt quite proud of.
We are prepared for the sea to chase after our dreams. Driven by both the global environmental protection trend and carbon peaking and carbon neutrality goals, China's offshore wind power is fully supporting the Blue Engine, and the installed capacity ranks first in the world. The technological innovation capability is one of the best. Being one of the best in the world and prepared to face international challenges, offshore wind power industry chain and supply chain in China are rising with the wind. While Made in China is proudly showing its ambition of marching into the ocean from the 18,000-kilometer coastline of China, it is also refreshing the world's perception of China's utilization of wind energy on the top of the earth. Zhigu Town in Komai County, Xizang, is a place that not just anyone can visit. The average altitude is close to 5,100 meters, It's a place of extreme coldness and hypoxia. The temperature is always 8.2 degrees Celsius and could get to minus 18.2 degrees Celsius at the lowest. Despite the complex and changeable climate, the abundant wind energy resources here make it the first location for ultra-high-altitude wind power research demonstration projects in China. Mount Yarlashampo is woven by dark rocks and white snow, and its peak is above the clouds. At the top of the mountains, a wind turbine installation unprecedented in human history is about to take place. The impeller diameter of Unit 5 is 131 meters. The capacity of a single turbine is 2.2 megawatts. As the challenger of today, it will try to break the limit of the height of 5,068 meters in altitude. As the installation height, which is a new world record, with the help of the engineers. The hoisting vehicle is in place. The tower with a diameter of 4.5 meters is pointing to the sky. The most critical wind turbine impeller hoisting begins. The crawler crane extends its long arm and slowly lifts the huge wind turbine impeller, with the auxiliary of the wheeled crane. The scene is astonishing, and danger is close by. The wind turbine impeller weighs 74 tons. To lift it to the top of a 100-meter high tower, the wind speed must be 8 meters per second for the operation to be safe. Engineers understand the consequences of a sudden increase in the wind force. That is not the only problem.
Wind conditions vary greatly. The window is only 1 or 2 hours long. When the window closes, we'll have to pause the project. I'm having severe altitude sickness. I feel like my heart is beating 190 beats per minute at the highest.
Jigu Wind Farm is the wind farm with the world's highest locating sea altitude. The total installed capacity reaches 22 megawatts. Half of the 10 turbines are from Sichuan. This type of direct drive wind turbine, with an annual average wind speed of 7 meters per second, can generate 59 million kilowatt-hours of clean electricity per year. Ultra-high altitude yields low average atmospheric pressure and air density, reaching only 60% of those in the coastal areas. That brings the wind turbine serious problems, including a serious drop in thrust or blade stall, etc. Harsh natural environment is one of the greatest challenges for ultra-high altitude wind turbines made in China.
This ultra-high altitude technology is leading both domestically and worldwide. This is an uncharted area. No one had the courage before. We've worked with 4,000 meters in altitude before. So, we just need to figure out what to change under 5,000 meters in altitude and solve the problems. We need to sort those factors out.
The extreme challenge is still underway. 2 meters per minute. Unit 5 wind turbine impeller is steadily moving toward the set height. Its direction gradually changes from the parallel to the vertical. After nearly an hour, the impeller approaches the turbine. Next, after some precise adjustments, the impeller is finally perfectly connected to the generator. After 5 months, the installation is finally over. The wind farm with the highest altitude in the world has smoothly started its trial phase. This is the day for routine inspections on the turbine. In the engine room 95 meters above the ground, Cheng Guiqiang, the engineer, is ready. The extravehicular mission that's coming up is life and death for him. Cheng Guiqiang's mission is to inspect and test anemometers and weather vanes outside the engine room. Because of the special geographical environment and climate, the wind farm often encounters strong winds and even thunderstorms, leading to an increasing chance of nacelle exterior devices damage. Spotting and fixing problems in time is the only way to keep the turbine functioning. It's a nice day outside the nacelle, but the wind is unusually strong. The wind speed is 10 meters per second, and the tower that is standing alone is slightly shaking from time to time.
The wind speed per second is 12 meters, now 13 meters. Hold it. Come in for now.
After 10 days, the unit will be inspected with critical standards. Chen Guoqiang wants every unit to be in its best state. For the final inspection, the real-time weather monitoring data from the wind farm shows that the wind conditions are complex and the wind force is unlikely to weaken shortly. To leave the nacelle without proper checking is unwise.
Slippery is common. You could fall. Our colleagues and some friends from the wind farm have taken pictures of us working outside the nacelle. Most of us. Don't show them to our families. Get ready to exit the nacelle.
All right.
After an hour, it's finally time to leave the nacelle. Chen Guoqiang carefully climbs out of the nacelle. There are no guardrails on the smooth nacelle exterior. The operation area is only 4 square meters. The only security measure Chen Guoqiang gets is the safety belt tied around his waist. Right now, the wind speed has dropped to below 10 meters per second, which is within the safe wind speed range of exiting the nacelle, but the oncoming wind is still strong on impact. Against the howling wind, Chen Guoqiang strictly follows the operation procedure and races against time to complete all the inspections and testing of exterior facilities. 5,068 meters in altitude. This is the new altitude made in China marked on the roof of the world. This number means that Chinese wind power equipment manufacturing enterprises are fully equipped to develop, manufacture, and install ultra-high-altitude wind turbines on their own. They've achieved the challenge of harvesting ultra-high-altitude wind power in no man's land at above 5,000 meters in altitude. The trend of the world gradually becomes clear. Starting with a lack of technology, China is now a pioneer in the world. This route of growth is full of twists and turns, yet still magnificent. It brought huge changes to China's wind power industry and profoundly changed the world's wind power landscape. Today, China's wind power industry leads the world in technology. Not only does it have independent research and development capability for large megawatt wind turbines, but it has also established a complete wind power equipment manufacturing industry chain. The overall strength and competitiveness of manufacturing enterprises have been greatly enhanced. The global energy revolution is in full swing and unstoppable. China remains committed to the path of green, low-carbon, and sustainable development, consistently advocating for a future of clean energy. Green has become the most prominent color in China's pursuit of high-quality development.